In this video, we're going to be solving the equation x over x plus 4 equal to 7 over x minus 5. This is a rational equation, so there's a few ways you can actually go about solving them, but we're going to solve it by first finding the common denominator. Okay, so common denominator needs to consist of every factor we see on the bottom to the highest power we see it in any one fraction. We only see x plus 4 and x minus 5 on the bottom. They were already factored. So that's our common denominator. The second step that we are going to do in the particular method that I'm going through here is to multiply both sides of the equation by the x plus 4, x minus 5. So x plus 4, x minus 5. I'm going to multiply both sides by the x plus 4 and x minus 5. Gotta squeeze that in there. There we go. So multiplying both sides by the x plus 4, x minus 5. And some things here should cancel as we do this. On the right side, the x minus 5s, and on the left side, the x plus 4s. Giving us just x times x minus 5 on our left side, and 7 times x plus 4 on the right. Now this is an equation here. So after doing that second step of multiplying and canceling, we just have to solve the resulting equation, which can look at a number of different ways depending on the resulting equation type. We're going to distribute out here so that we can see what type of equation it is. X times x is x squared. X times negative 5 is negative 5x. Distribute the 7 through, so 7x. Plus 28. Now that I've distributed things out, I can tell that this is a quadratic equation because of the exponent. So I need to move everything to one side and solve it as a quadratic. So I'm going to subtract 7x on both sides. And I'll also have to subtract the 28. On the right side is everything is canceling, so I'm going to have x squared minus 12x minus 28 on the left side equal to 0. We do still have to solve the quadratic, but one piece of advice I like to point out with this is when you are solving, make sure x squared is positive. It usually is more helpful in most cases, especially if you're going with the factoring method. So now that we have it equal to 0, we can solve it in a few different ways. I'm going to choose to use zero product property and factor. Since there is no leading coefficient, factoring is pretty quick. Multiplying the first and last, I have negative 28x squared. And the combination of factors I need to add to be negative 12 is going to be positive 2 and negative 14. Since there is no leading coefficient, I can jump straight to the factors of x plus 2 and x minus 14. To finish solving this, we set each factor equal to 0. And just solve those one-step equations. So x is negative 2 and x is 14. Now you do have to also remember that this is a rational equation and not originally quadratic like that line there. So we need to double check and make sure that we don't have what are called extraneous solutions. Now extraneous solutions are solutions that are algebraically sound but do not solve the original equation. In order to check for the extraneous solutions, what we really need to check is the restrictions of the original equation. We need to see if either of our solutions make the bottom of the fractions 0. So currently the bottom of the fractions, if we have x over x plus 4 equal to 7 over x minus 5. So our x values here, if I check them, my first x value is negative 2, and negative 2 does not make the bottom of the first fraction 0, nor the second fraction. So negative 2 works perfectly well. And if I try 14, 14 plus 4 is 18, and 14 minus 5 is 9. It's not 0, so we are good. The only issue that comes about is when we have 0 in the bottom of the fraction. You can also double check it in its entirety by plugging in the 14 on top as well and just verifying that you've indeed gotten the correct solutions without any mistakes. I usually only check for the extraneous solutions for these equations, but if you want to verify your solution, you can just double check all the way. So that's what I'm kind of doing here, where I'm just blabbing. As you can see, I checked 14 the entire way through, and it does match up. That's up to you whether you actually check it the full way, but what causes the issues with rational expressions or rational equations is the bottom of the fractions. So that's the main thing that you need to check, because you can't have 0 in the bottom of a fraction.